Hello, everybody. Welcome to the fourth day of our conference. We are so happy to open the day with the lightning talks from our community members. The first presentation will be by Nathan Willis, and the title will be Digging into the Front Family Plot. I hope that you will enjoy all our presentations, and we'll officially start in very few minutes. Thank you.
So how's my volume? I think I'm just going to lightning into it, if that's all right, because I don't want to slow anyone else down. Okay, I'm going to share an application window. See how that goes. All right. So yeah, digging into the font family plot. You might know I'm currently doing a PhD at the University of Reading. Those are my supervisors, and I get a scholarship from them. I mention that because I'm supposed to, not because of this talk. This is a tangent to that, but it is a tangent. I'm doing a big research project, and in fact, you can go participate in it yourself right now if you want to, or right after the talk is over. But I've never really had a lot to say about this research at FOSS conferences until this bit came up that I'm going to talk about now. And I'm here to tell you that your fonts are lying to you, or more specifically, maybe some of the information in the OpenType tables are. Like, you're probably familiar with the ways of describing width and weight of a font, like CSS. The thing is, though, that you can't rely on things like CSS weight numbers and width numbers any more than you can just rely on the name of the font being extra bold to tell you what it's going to look like. And so my research involves testing a lot of fonts, and I want to make sure that I test a variety of them, not a bunch that all look the same and don't really add any new information. And so finding fonts that look different is kind of a challenge. And I also want to find families of fonts where there's related shapes. So only one thing is changing if I'm changing the width to narrow, from narrow to wide. And if you dig into these numbers, like CSS widths and weights in a font file, the problem is clear. They're not actually measuring anything. They're just sort of numbers. For instance, here's some widths and weights on some fonts, and the 100 is not twice as big as the 200. It's different between any two fonts. It looks numeric, but really it's at best just sort of an ordering, and it doesn't even, the relationships between those widths and those weights don't really hold up between two fonts or between two fonts in the same family even. And the big issue here is that these numbers are what get exposed to people when they're trying to choose fonts in software interfaces. And so that's confusing. But you can get at the real underlying idea of what the width or the weight is by just sort of measuring the letters. And after all, that's what you do with your eye when you're looking at things. So that's what I ended up doing, directly extracting and processing the contours and the proportions from a whole bunch of font binaries so that I could choose fonts to work with. The tricky parts there are just sort of figuring out what things are useful to measure and then dealing with all the corner cases, because there's a lot of those fonts. Essentially every font is a corner case. But this means things like how tall the letters compare to each other, how thick are the strokes. In Latin, the thickness of those verticals is basically what we mean when we say weight. How wide are the interiors, or the round and straight, it's different. So all in all, about 30 different things I measured directly from the font binaries. I set out to do this for my experiments using a whole bunch of Python stuff. The excellent font tools library, it went much faster than I expected, though, so I kept going. I mean, say what you will about the weirdness of font binaries, they're very efficiently packed, so they're very efficient to process. It did the entire Google font library. It did everything I could get in Debian that worked. There's some weird like conditions there that don't always work together. Random things that I had that were just like free to use, but not free to redistribute, that sort of thing. Took a bunch of measurements. The results were, I was pretty happy with how they worked out. So I think those things are sort of ordered in the way that we really think about weight. But it's interesting just to look at the data for how other people can use it too, how normal people not doing a research project. And for that, I'm going to switch tabs. This is just a dashboard that I made that is extracted from my actual research software to look at. And you can see, all these raw numbers, but where it gets interesting is when you plot groups and families of fonts together. So this is that CSS weight problem I was telling you about. It looks like everything falls into these few little categories, but the weights are actually really spread out there. And you could sort of slice through there and get anything at any CSS weight. And the real distribution is really a blob like that. Same is true with the widths. You only get a few numbers to choose from, but it's really a lot more spread out. Why does this matter? Well, if you just plotted the numbers that are in the fonts, you'd think, oh, look, we've got everything covered here. But in reality, it looks more like this, right? Which is very clumpy, and it has all these weird striations to it, and that's what you see with your eye, and it's sort of hidden from people. You can also, just looking at the reported values, maybe they don't tell you everything, but you can dig into them to find things. So this is where the italics are. This is where you see monospaces. Monospaces are not as widespread as italics. Does that mean something? I don't know. There's a lot of ways to sort of dice that up. One of the things here is the contrast ratio, how the relative difference between thick and thin. For type people, that's like one of the most important things, and that's nowhere to be found in a font binary. And you can look for weird things that don't add up, like it says the X height is this, but when you measured it, something else. The other thing I think is useful to look at is families. You don't really see looking at font families in an interface anywhere, but this is in Consolata, the monospace font everyone knows. It's very spread out where all the weight and width is. And just compare that to Noto Sans Mono, which is all kind of basically the same. So that might be something that's useful to you when you're choosing fonts that is sort of not exposed anywhere else. I think choosing fonts is confusing, but it doesn't have to be. And a big reason that's confusing is this mismatch between those numbers like CSS weights and what people actually look at with their eye. This direct measurement stuff, it's not really info that's available at the package level, so I don't see that being in a font manager necessarily. But you could do it to choose a font in an application, or if you're looking at a big project and you want to see a family that covers everything you need. That view of things is maybe more interesting for people. That's about it. Like I said, Google Fonts and Debian, there's a big archive. There's some others that are possible. It kind of depends on the API. Open Font Library doesn't have one. And then the last thing I want to end on is that everything I've shown is basically Latin because I don't read very many other scripts. But one of the nice things is that knowing what to measure depends on the language. So font formats like OpenType were created in Europe and North America. They don't cover what's important in writing Arabic and things like that. So you can shoehorn it in, or you can measure it directly. Measuring it directly is pretty fast and not so difficult. So it's useful. I also have all this data. If you have questions about fonts in general, just hit me up. And that's my time. Thanks.
Hi, shall I start? Need to share my screen. Hi, can you see my screen?
Yep. Yes.
Good. So yeah, welcome to my talk. Actually, it's on the last page. This is the sounds of the Berlin mini GUADEC that you're listening to. Anyway, so I want to do a quick demo of how you can use ZBus to write applications, simple application, and a service in Rust. But I couldn't there's too little time to do an actual live coding session. So I have written the code already, but I will go line by line. So I think that should suffice. And then we'll see it in action as well. Yeah, ZBus is a dbus library in Rust. And it's just about making dbus in Rust as easy as possible. So what we will do is make a fake geoclue service. Some of you might be familiar with the service. It's a geolocation service. So let's start it. Let's start with the service part. I'm sorry, I'll have to go very fast with this. But if you have any questions, I will be very happy to answer them later in the chat or on Matrix. So these are all the imports that we will need to create a service. That we declare on the top, normal ZBus stuff. ZVariant is part of ZBus that does the serialization, deserialization, and of course the Serder library in Rust that does the serialization, deserialization. It makes it very easy. So what do we do with the geolocation? Well, we want to know the location. So how do you represent location? That's how latitude, longitude, and we derive some simple types on it. And then we create our service. It's a simpler version of GeoClue, so it's not exactly the same API. Just mind that. We create a struct. For a fake version, we don't need a state, so the struct is a simple struct without any data. How we do it? We do an implementation of GeoClue with the implementation in this space, but we use the ZBus macro, which is dbus interface, and we declare the interface name. And what goes in the implementation is, for example, a signal. We have a signal that will be emitted each time location is updated with the old and the new location. The location structure you already saw. And we have a special representation for it. So you do this attribute, macro attribute, dbus interface, and you say it's a signal. So it doesn't need an implementation. It just needs a declaration. And the actual method we have is a start, where we just tell the service that you start locating me. And since we have a fixed service, we just as soon as we are told to start, we just do it and we give a fake location. This is the location of our mini GUADEC here in Berlin. Location, and we emit the location updated signal just like calling a method. We need to expose it on the bus. So we create a session bus connection. And then we create something called object server that serves your objects in the service. And we request a name on the bus at the same time. And we tell it what to serve in which path, object path. And then we loop and try to handle all the requests that comes from the client. Server side done. Let's run it. Here we have it. I have the code here, created the project. So it's the same code. Cargo run, and it compiles first. Of course, it had to compile again. While it will compile, it will run. Okay, now it's running. So the service part is running now. Now we go to clients. And now let's write the client, which is the app. Again, all the imports. I have grayed out all the ones that are common with the server side. So these are the different implementations. So this time we will need to deserialize rather than serialize. So that's why it's a bit different. And also instead of dbus interface, we use dbus proxy macro. Again, we need the same location, but as I said, instead of serializing, we need deserialize. So that's what we define here. And then instead of dbus interface, we create a dbus proxy. And since we will not be doing any implementation as a client side, we define a trait, which is like an interface in other programming languages. And we declare the service, the interface name, and the default path of the main service. Same as we did on the other side. And then we define it's the same methods, but as you notice, the start method is now a declaration only because we will be calling on the remote side. And then same as before, connection, and then we create the macro gives us a type called GeoClue2 proxy because we created GeoClue2 trait, so it creates against this GeoClue2 proxy type, which is the proxy for the remote. And we give it a connection, and then we have a connection to GeoClue, and we connect to the location updated signal. And when we get the signal, what we want to do is this is a closure we are passing, and we just print the new location. And then once we have connected to the signal, we tell it to start, and then we just process the next signal that arrives on that interface. All done. So let's try it. So this is the service running already. On the other side, I have the client now. I hope you can see my terminal clearly. And of course, this also needs to compile again. I should have compiled this before. But yeah, the demo effect, I guess. All right, so it did its job. It got the same latitude, longitude from the other side. Yeah, that was it. And that was my simple demo that shows the power of ZBus to create dbus app and service very easily in Rust. Thank you for being here. And as I said, ask me questions on Matrix or chat. And we also have a Twitter account for our crate, ZBus crate, and also myself on there on Twitter. So you can ask me there as well. Thank you so much. That's all from me. Hello.
Testing. Am I audible now? Is it working? Good. Good, good. Hi, everyone. I'm Nirbhik. Some of you may know me as the guy who broke all your build systems. Everyone knew that AutoTools was fine, and no one had asked for or wanted Meson. And now look where we are. Anyway, getting to the topic, Rust. Big mistake. I have a long history with C. It was my first language and my favorite language. That's actually a lie. I think today I should come clean. My first language was actually C++ in school back in 2003. I know, I committed blasphemy, C++ is haram, but I hope I have atoned sufficiently for my sin by never enjoying C++ in my life. Anyway, the first language I actually enjoyed programming in was Bash. Okay, don't give me that look. Then Perl. Okay, I can feel you all judging me. Then Python. And finally C. And I liked it more than anything else. It's a fast language, it's a simple language, and it works everywhere. I learned how to program in the age when computers had 200 megs of RAM and your software was either fast or unusable. Granted, the C library isn't that great, but that's why we have glib. Which, shout out to glib, by the way, cannot imagine writing C without it. C is not perfect, but I've written it for over 10 years, and I was happy through it all. Sorry, that's another lie. I'm sorry, it hasn't actually exactly been a happy relationship. I mean, I should know better than to use an L value after freeing the object it's pointing to. After all, I'm the one who did that. It's my fault. C has always been upfront that any L value could contain what it declared to contain, or null, or just garbage. Personally, I think it's a bit quirky that there is such a thing as a valid-invalid value, but who am I to judge? I signed up for this. But eventually I realized that she deserves someone smarter than me. I'm too dumb to not make these mistakes. I tried to be better, but I am just not good enough. So when I heard that there's this brand new language that gives the same promises as C, speed, simplicity, portability, interoperability, and doesn't need me to jump to be the reincarnation of Bodhisattva Dennis Ritchie, I jumped on the bandwagon. In retrospect, I am grateful that I wasn't one of those obnoxious Rust evangelists who have discovered the fastest way to file an issue in your GitLab just to tell you to rewrite the whole thing in Rust. Because in the end, I actually regret everything. I jumped on this bandwagon back in 2018, and at first, all the promises seemed true. The syntax was a lot like C, with explicit typing and casts, pointers, structs, enums, functions, everything. And best of all, I didn't even need to manually manage memory anymore. The compiler did it for me. I was so happy about this incredible advancement in computer science. But something changed this year that has soured my relationship with Rust. I used it in an actual project, not just some toy side project to learn things. And now I hate what it has done to me. I don't think I can take it anymore. Using Rust for a project that project has objectively reduced my overall enjoyment of life. For one simple reason. I still need to write code in C. I spent weeks on that project writing mostly only Rust. And when I emerged from my cave back to C, I was astounded. Nothing made sense anymore. Why is it that enum fields are separated by commas, but struct fields are separated by a semicolon? Why do we need parentheses around if and for statements? Why can't I return multiple values from a function? Why can't I compare strings for equality or use them in a switch statement? Is there some special way to compare strings other than byte for byte? At the end of it all, I can now write a 5,000-word essay on why const is the most useless C keyword in existence. The project I mentioned earlier had a large Rust server component and a smaller C client component. So you can imagine that I had to implement some utilities in both Rust and C. That was where the chasm between Rust and C really became evident to me. There are a ton of examples, but time is short. So I picked the one that really depressed me, so you can all suffer with me. I had a data structure, which was a hash table, where the keys were strings and the values were another hash table. This time from strings to G values. This is what the definition looked like in Rust. Straightforward, right? So I wanted to document the semantic meaning of each string. So I wrote it as this. Super simple, self-documenting, easy to understand, very cool. This is what the definition looked like in C. I want us to take a moment here to properly appreciate how useless that definition is. You might say, oh, just look at the place where you initialize it. But don't forget that this is a nested hash table. You need to hunt for all the places where objects are inserted, and hence allocation might be needed to get the full picture. Honestly, trying to understand data structures in C often feels like this. The situation gets even worse once you start dealing with more complicated structures. So earlier, when I showed you the hash table in Rust, I lied. The Rust implementation's hash table was actually a triple nested hash table since it had to deal with multiple clients. And unlike the C version, it was asynchronous and multi-threaded. So I made it thread safe in a way that was guaranteed by the compiler with granular nested mutexes. This is what the type signature looked like. I did not even blink while using this thing, and to top it all, I never once had a bug or a race in this or any other data structure I used in that project. You might ask, how is that possible? Well, mutexes in C protect code, so it's your job to make sure to do the right thing in that code. Mutexes in C are a container that protect the data structure inside of it. It's impossible to get a race. You can deadlock, of course. On top of that, you don't need one big lock to protect your entire structure. You can have separate locks for each piece. In the previous example, the property cache for each element, for each client, was locked with a separate mutex. So there is no contention at all. Best of all this detail is self-documenting. You just need to document, you just need to glance at the type signature. I mean, in C, just the thought of documenting a structure like this gives me a headache, let alone implementing it and using it correctly. But the sad reality is that I will have to, because our entire Linux ecosystem is written in C. And we still haven't solved some fundamental issues with Rust. Cargo! That would allow it to be integrated as a first-class citizen in our stack. Writing a large project in C, in Rust, and going back to C kind of feels like the life of Charlie from Flowers for Algernon. Having seen the truth and tasted what could be, I can never be happy in my old life again. So the moral of the story, this fable, adage, slice of life is, don't repeat my mistakes. Stay away from Rust. Ignorance is bliss. Happiness is everything. Thank you. As an aside, Dylan Baker has been doing some tremendous work on Meson integration for Rust and Cargo projects, so there is still hope. That's all.
So our next presentation is from Thomas Chen, but I'm not seeing Thomas on the chat. So let's wait for a few more minutes to see if Thomas is joining. So it looks like the next speaker is not joining as well. In case that there is someone who'd like to improvise a 10-minute lightning talk, let me know. I can give you the right as a presenter, and you can go ahead. Thank you.
Hello.
Yeah, works.
Yeah, I have 2 minutes. Let's see. Yeah, so the tutorial you saw from me of ZBus was for 1.0 mostly API, but we have the 2.0, and the main difference, let me share my screen again. Oh, this time, that screen.
Oh, you might need to.
This is now, yeah, it is a now Rust stream. Okay, so I found the presentation material from another talk for the new API. So for 1.0, we didn't have asynchronous API, and in 2.0, that's our main thing that is coming up soon, hopefully. And the problem with asynchronous in Rust is that that's one side of Rust that's not very mature, like yet. It's kind of getting there, but it's not really. And you have multiple runtimes. Like think of it as main loops. In glib you have one main loop, but in Rust you have now multiple implementations, especially to Tokyo and async std, and they don't like each other or something. And so it's really hard to write code that works for both of them out of the box. So that has been our main challenge, writing these async APIs, the 2.0. But we have had success, and the low level is already done, and it looks very similar to how we have it in the synchronous world. I have again dimmed out the parts that are the same as the synchronous parts. When you call methods on the connection, and then instead of just that, you also say .await for waiting for the asynchronous call to return. So, and the client side top level, we also have that. So you saw in the previous example I showed, like GeoClue proxy. Am I out of time?
All right.
Yeah. Okay. So it was the macro created a proxy for us. So similarly in here as well, it will create a proxy, but it will also create an async version. So that's what we are using here. And then this is the notification service we are calling from the client side. And yeah, you just .await again. And signals and properties we can do as well, like the same as before. But again, it's asynchronous. So if you in the signal handler, if you want to do something asynchronous, you can do that with this. Also, like method calls, you just .await, and then it's async only done. Same again, .await. But there is also a cool new thing with async in Rust. It's called streams. So if you want to receive a lot of things asynchronously over the network or something, or socket in this case, you can use something called streams. And the way it looks is like the proxy also gives you something called receive signal, and then you can create a stream for all those received signals of this name, and then you process it. You say stream.next and .await, so you wait for the next signal on the stream. And that's how it's done. Actually it's very similar. It's almost the same as what we had before, the old and new location. Receive. But you also get like a more type safe. Like if you declare your signals with the macro, with the dbus proxy macro, you also get this API. Which is specific to the signals you have declared with type safety. So then you don't need to tell it how to deserialize the signal, but instead you get the arguments, signal arguments, and it knows already the types of their types, so it just knows how to deserialize. A bit easier. Server-side async we don't have, but we are working on it. It's coming soon. And that would be to 2.0, and the APIs we already have, we do the beta releases, so you can already use them and you can port them slowly.
You have 10 more minutes.
Okay, have 10 more minutes. Okay, but yeah, if you want to try out 2.0 already, the beta releases are out there. You can use it, but you have to explicitly ask for a specific beta release in your cargo toml file if you want to do that. But yeah. that's what I thought. I'll present while we are waiting for someone. Yeah, okay, that's it for me.